Lesson 6.2, Properties of Rational Exponents. So there are a lot of different types of problems we're going to be working with today, so you might refer to your textbook, page 420 to page 423. I have examples written, and then we're going to work through some problems. Notice this first one when it says we're adding exponents. Because the examples I have here are fractions, sometimes you're going to need to find a common denominator. So that's what we'll start off with down here. So we have an 8 and a 6. So if I multiply the numerator and denominator by 3, we're going to get 12, 3 over 24. And then for 5, 6, we're going to multiply by 4. So 12 and then 20 over 24. Now we have like denominators, so we can just go ahead and add. So 12 and then it's 23 over 24. The next example, we have this entire expression raised to the power of 3. So 1/3 times 3 is 1, so that just becomes 5 to the 1, or 5. And then 1/4 times 3 will give us 7, and that'll be raised to the power of 3/4. This third example is similar to the one we just did, except that we have a -1/6. So because it's a little bit more complicated, we'll break it into 2 sets of parentheses, and then times 4 to the 6th times -1/6. And it's just a little bit easier to see. So -1/6 times the 6 will give us 2 to the -1 times 4 to the -1, and we know that this negative sends it down to the denominator. So we end up with 2 times 4 in the denominator, a 1 in the numerator, so the final answer for this one will be 1/8. We have one last example to squeeze onto this slide. This section is just going to take a lot of practice, but I think it's kind of fun. If we look at this next example, we see that we have the same exponent, 1/4 and 1/4, and we notice that the 56 is divisible by 7. So let's break that up a little bit, and we'll say 56 divided by 7, and that entire fraction is raised to the power of 1/4, and then that quantity is raised to the power of 5. So we're working backwards just a little bit. Now we can say 56 divided by 7 is going to be 8 to the 1/4 raised to the power of 5. And our final step will be to multiply 1/4 times 5. So 8 raised to the power of 5/4. Just like when we were working with plain old square roots, we know that we could multiply, in this instance, the a and b together, or sometimes we might need to factor what's underneath the radical. So let's try one. We notice that each radical is a cube, so we're going to go ahead and multiply 12 times 18, and we end up getting 216 under the radical sign, and 6 times 6 times 6 would be the cube root. Another way we could have worked with this one, we could say 12 to the 1/3 times 18 to the 1/3, and that would be the same as saying 12 times 18 raised to the power of 1/3, and then we'd still get our answer of 6. So whichever way works best for you. Now let's look at the quotient property. All right, so I started it already. We have 96 with the root of 5 and 3 with the root of 5. Then I rewrote it using exponents. So after I did that, I'm undoing the problem. I have my set of parentheses, and I raised 96 over 3 all to the 1/5, because if you remember, I could go backwards and multiply both of those by 1/5 and get back to this answer. But anyway, so we have 96 divided by 3 is going to be 32 to the power of 1 over 5, and that simplifies to 2. So 2 times 2 times 2 times 2 times 2 would get me back to 32. Our directions here say to write in simplest form, and I put a reminder that you may have to factor in this section. So you could use a factor tree or you could list. So I'm going to begin with listing. I know that 2 times 52 is 104, but it's cubed, so we're trying to find the same value 3 times that goes in, that I can take out, that would go into 104. So we'll keep going. And I'm going to say, well, 52 is the same as 26 times 2. So I have my 2, and then 26 times 2. And I can factor some more. Then I say my 2, 26 is the same as 2 times 13. But then I still have this 2 that I need to include. And now I have all prime factors. And I can see that I have 1, 2, 3 2's. So that would be 2. I have to include my little index of 3. And 13 is left underneath the radical sign. Now we need to simplify this guy. And this is going to take a little bit of manipulation. So I can't really do anything to the numerator right at this moment. So I'm going to keep it just as it is. And then let's go ahead and factor the denominator. And I know 27 is 3 times 3 times 3. So I have 3 3's, but it says we need 4 of them. So we know if we multiply the numerator and denominator by the same value, a form of 1, it's not really changing. We're just changing the form. So that's what we're going to do next. So now I have 10 times 3. So I have my index of 4, so that's 30. And then now we have 1, 2, 3, 4 3's, so I can take out 1 3. Our final answer here is the 4th root of 30 over 3. All right, home stretch. So you can kind of think of this first example similar to if I had adding like terms 7a minus a. So we have the same root and we have the same value underneath the radical. And we know that we could think of there being a 1 in front of it. So that would simplify to 6 and then 5 radical and then the 12. Our next example with fractional exponents, it's the same thing as working with a radical expression. So we're just going to add the 2 and the 10. So 12 and then in parentheses 8 to the 1/5. This third example does not have like terms, so we're going to have to manipulate it a little bit. So I started off by factoring the 54 to 27 times 2. Then 27 I know is 3 times 3 times 3. So I could take out that 3. Now we have the first term, subtract the second one, and we can imagine there's a 1 in front. So it simplifies to 2, and then we have our 3 tucked in there, and then radical 2. Next, we're going to simplify with variables. So for the 625, you might use your calculator. You can also see that it ends in 5, so the likelihood that it's 5 times 5 times 5 times 5, did I say it 4 times? So it does turn out to be a 5. And then for our z, remember we can put the power over the root. So that is going to simplify to 5z, and that's raised to the power of 3. You could also imagine if I had the 625 and then I had 12 z's listed, and for every 4, for every set of 4, we take those out, we would end up with 3. All right, the last one that we're going to look at. We know that we can write the m as 6 over 6 and the n 18 over 6. That would simplify to m and then n cubed in the denominator.